Hello, everybody. So today we're going to be going through Gym 103 Final Exam Review number 1 and hope to prepare you for your final exam in 103. So we're going to be going question by question. I'm going to kind of make sure I write out all the details. And if you want to kind of follow along with the same review sheet, we're doing review sheet number 1. And you probably want to use the PDF for video because I've edited the format so it's different than the print version. But we'll just kind of get started here. So as we kind of go through, we're going to talk about each question and kind of little tricks and like how we can use our calculator to help us on some of them if it's a calculator type question. So let's get started. So number 1 here. So we're asked to simplify the following expression. So when doing this, we have to keep in mind the order of operations. So if we remember, the order of operations is PEMDAS. So we have P, E, M and D, which come at the same time, and then A and S. So it's a good mnemonic to remember, but we got to remember there's only 4 kind of levels of priority here. So it's P first, which is parentheses. So we're going to do anything in parentheses first. And if you have multiple sets of parentheses, you're going to work from inside to out. Then next we would do any exponents. Then after exponents, we're going to do multiplication and division. Those come at the same time, and we work those left to right in our equation. And then addition and subtraction, again, same time, left to right. So we're kind of go through here. We do have multiple sets of parentheses here. We have our brackets, which are also parentheses, and we have the parentheses inside those brackets. So we're going to work our way inside to out. So the first thing we're going to have to do is make sure we simplify inside the parentheses, which are inside the brackets. So what we're going to do is we're going to say, okay, well, we have -3 plus 1 inside those parentheses. That's going to make -2, and that is being squared. So now that we're looking at this, we're still working inside those innermost brackets here. So we got an exponent inside these things. So we're going to have to take care of that next before we do the multiplication of the -2 on the outside. So what happens is we're going to have 6 divided by, we have -2. Now -2 squared, we can punch that in our calculator, or we could just think about what that is. If you're going to punch it in your calculator, you have to be very careful about using parentheses because that negative needs to be inside the parentheses just like it is on the screen here. Otherwise, your calculator will give you the wrong result because when we square a number, it means we're going to multiply it by itself. So -2 times -2 or -2 squared will be a +4. So now we're going to still be working inside our brackets here, which is a parenthesis. So we got -2 times 4. So we're going to do 6 divided by, we got -2 times 4 is -8. So now 6 divided by -8, well, that doesn't divide evenly if we check that in our calculator. So we're going to need to write this as a fraction at the end. So when we do division, it's the same thing as doing a fraction. So we have 6 as our numerator and -8 as our denominator. Now, if you try to punch this in your calculator, it will not allow you to do negatives in the bottom of a fraction. So you would want to move that out to the outside because that would be equivalent. So another way to write this would be -6/8, okay, which would be easier to punch in our calculator to simplify for us. But now all we got to do is simplify. So if we simplify, 6 and 8 are both divisible by 2. So we can kind of simplify this down as negative. So 6 divided by 2 is 3. 8 divided by 2 is 4. To get our final answer of -3/4. Okay, so just remember when we're doing order of operations, follow our order, multiple sets of parentheses inside to out. Then we jump to exponents. Then we do multiplication, division. Then we do addition, subtraction. And again, 4 levels of priority. And we try to work left to right when we get to M and D and A and S. Okay, so we're going to move to the next one. So number 2 here. And this is kind of number 2 is going to signify the importance of parentheses when we do exponents specifically and just in general how important parentheses can be. So we have to be very careful because a lot of these we can punch right into our calculator. But if you punch it in the wrong way, it's going to give you a bad result. So we have to make sure we're punching these things in appropriately and know what they mean so we know we've punched it in appropriately. So if we think about A, so A is saying we want to do -4 squared. Now notice in this that the -4 is not in parentheses. So that signifies something that these are not kind of tied together as we think they might be. So what -4 squared really means is that there's an imaginary -1 sitting on the front of this, and we're really just doing 4 squared, and we're going to multiply that by -1 at the end. Okay? So if we do that, well, we're going to do the exponent first. So 4 squared is 16, so this becomes -1 times 16, which equals -16. And if you were to punch this in your calculator and you would have put parentheses around it, it would have gave you +16. So you got to be very careful if it has or does not have parentheses, because they do mean different things. So for B here, now it does have parentheses. So now when it has parentheses around the -4 before the square, that means we are squaring -4, okay? And two negatives multiplied by each other are a positive. So if we were to punch this in our calculator, we would have to make sure we put parentheses around it, or it will give us a bad number. So when we say -4 squared, what we really mean is -4 multiplied by itself. And again, two negatives do make a positive when we multiply. So this would actually turn out to be +16. So the importance of parentheses are shown here, that when we don't have them, it isn't +16, but when we do, it will definitely be +16. So now for C, this is a very good one just to punch in if we have a calculator. So 4 cubed. Well, 4 cubed means we're going to do 4 times itself 3 times, and 4 times itself 3 times should give us 64. Okay, so for D, we have 2 times 4 squared. So again, order of operations are important. So since that 2 is outside the parentheses and it's not being squared, we know we have to do the exponent first. So we're going to do 4 squared first. So 4 squared would be 16. So 2 times 16, which ends up with a final answer of 32. So be very careful how you type things in. Usually, if you type it in exactly as you see it, your calculator is going to do just fine, depending on the calculator you're using. All right, number 3. So for number 3 here, we're asked to find the least common multiple of 3 expressions. Now, a least common multiple is a thing that is an expression that all 3 things that make it go into, meaning they divide evenly into it. And we want the smallest such thing that they divide evenly into. So we don't want to just pick something super big. We want to make sure we find the smallest such thing that all of these will divide into. So the way we kind of do that usually is with prime factorization. Okay, so prime factorization is the most efficient way to find an LCM. And it's the most useful way, especially if your numbers and expressions get quite big. So what we'll do is we'll kind of make a prime factorization of each expression that we have in question. So I'll kind of write them out here. Okay. And I like to do it horizontally just to kind of visually see it better, but you can do a tree if you like a prime factorization tree. Just be careful not to lose anything. So 4x squared can be broken down because 4 is 2 times 2. And then x squared can be written as x times x. So we're kind of breaking down into our prime units here. And if we can keep breaking them down, we're going to keep going. But if not, we're going to stop there. So 2 times 2, 2 is prime, so we're going to stop. So now 6 is 3 times 2. And then we have an x, and we have y cubed, which means we're going to have 3 y's multiplied. Okay. So 3x squared, well, 3 is already prime, so it's going to stay itself. We're going to have an x, and we have a y squared, so we're going to have 2 y's listed. So once you have your prime factorization, now we're going to ask ourselves, how do we find our LCM? So to find an LCM, we are going to look at each list and each factor that happens in that list. So in our case, our factors that we're talking about are 2, 3, x, and y. Those are the only things that show up in any of the lists. So we're going to have to consider each one of those and determine how many we need in our LCM. So when we're doing this, what we're doing is we're trying to figure out the most that any factor occurs in any one list. Okay, so not all of them together, but just the most that happens in any one list. So, for example, when we find our LCM, we're going to look at our 2's first. So if we look at our 2's, our first list, the 4x squared list, has 2 2's in it. The 6xy cubed has 1 2 in it. and the 3xy squared has no 2's in it. So the most amount of 2's we had were 2 in that first list. So our LCM will also have to have two 2's, but only 2, okay? Now we're going to look at our 3's. So our first list has 0 3's in it. Our second one has 1, and our third one has 1. So the most was 1. So our LCM will have 1 3 in it. Now we're going to go to our x's. So our first list has 2 x's. Our second has 1. Our third has 1. So the most was 2. So we're going to have 2 x's in our LCM. And then now as our last is y that we have to check. So 0 y's in the first list, 3 y's in the second, and 2 y's in the last. So we're going to have 3 y's as well. So we're going to have 3 y's in our LCM. Now, once you've kind of considered all three things or all your factors, now we're just going to put everything together again to make our LCM. So 2 times 2 times 3, that's going to be 12. X times x is x squared. And y times y times y is y cubed. So our LCM will be 12x squared, y cubed. And I would say if like that's one that gives you trouble, practice that one for sure, because you're going to see it. Finding LCM is important, especially when it comes to fractions. You need it in future classes. So it's a pretty big concept. So make sure you practice that one if you're unsure or like not super comfortable with it yet. All right, so moving on to number 4. So we're asked to simplify the following expression. So in this expression, we are subtracting two different polynomials from one another. So it's important that when we're subtracting, when we have parentheses like that, that negative right here, so that negative applies to the whole set of parentheses that follow it. So you can think of it as like a -1 being multiplied by that second set of parentheses. So we need to distribute that first. Okay, so if we're going to distribute that, so we got to distribute this negative to all three of the components of the following polynomial. So if we do so, we're going to have a new expression. We're going to have 4a squared minus a plus 8, because our first polynomial is not being multiplied by a negative. Then we're going to distribute this negative. So -1 times a squared will create a negative a squared. -1 times 2a will create a negative 2a. And then -1 times -3 will actually create a positive 3 now. So now that we've distributed the negative, we no longer need the parentheses. We've kind of taken care of that operation. Now we're going to combine what we call like terms. Okay, so a like term is any term that has the same variable to the same exponent. Okay, if so, we can combine those. So think of it as like objects, right? So if we have apples and apples, we can combine that to make more apples, right? But if I have apples and oranges, I can't say I have, this many apples, oranges. So like they have to be the same thing. So in our case, our like terms, we have a 4a squared and a negative a squared. And if we want, we can think of there as like an imaginary -1 in front of these if we need it when combining. So if I have 4a squared minus 1a squared, well, we now combine those coefficients. So 4 minus 1 creates 3. So that's going to give us a 3a squared altogether. And that takes care of our a squared terms. So now our next set of like terms, we have -1a and -2a. So if I have -1 and then I subtract 2, I'm now going to have -3. So I'm going to have -3a's altogether. And our last set of like terms are our constants here, +8 and +3. 8 plus 3 will create 11. And then once we have that, we've combined all of our like terms. This is as simple as we're going to be able to get this one. So that would be our final result. But you have to make sure they're like terms before we add them. So make sure you're not just adding everything together. They have to be a like term in order to do so. All right, so number 5. So in this one, we're asked to evaluate an expression given the values of our variables x, y, and z. So the first thing we're going to do is want to plug these things in for the variables, but we have to be very careful with negatives. So usually when you plug in a negative number, you're going to want to make sure you put it in parentheses to know that it was a negative number that you plugged in, not a minus, okay? So We're going to plug things in. So our y is -4, but notice there's already a negative on the y, so we're going to have -4 squared plus x, so +2, over z, which is going to be -2. And again, if we want, we could put that in parentheses, but since it's the only thing on the bottom, we're just going to leave it as -2. Now we need to simplify. So again, we're going to kind of focus on the top first before we divide our -2, because even though there's not like implied parentheses here, we can think of this as like all one thing being divided by -2. So we have to do it first before we do the bottom, okay? So first thing we're going to do is our exponent on top. So -4 squared would be +16. So this is going to give us -16 plus 2 over -2. Now we're going to combine our two terms on top. So we have a -1 times 16 is -16 plus 2. So it's going to become -16 plus 2, which is -14 over -2, which results in a +7 because two negatives being divided would be a positive. So again, be very careful how you plug things in. Once you kind of get to your first step where you plug the numbers in, you can punch it into your calculator as is. You just have to be very careful how you type it in. So again, if you were going to punch this in a calculator, you would need to make sure you put parentheses around the whole top before you do the division in the calculator. And then you'd also want to make sure you have parentheses around your -2 when you type it in, just to make sure you know it's doing what it's supposed to be doing. And if you typed in exactly as you saw it right there with all the parentheses, you would have exactly what you would expect to get. All right, number 6. So it's asking us, we have a number line here. It's asking us what fraction is being graphed on this number line. So when we think about fractions, we're talking about parts of a whole. Okay, so like whole numbers are like 0, 1, 2, 3, 4. Now, if we come in between those numbers on a number line, then that will be a fraction. It will depend on how many segments that interval has been broken up to, what that fraction will look like. So what we would want to do here is kind of count how many segments get us from 0 to 1, because that is our whole number. So what happens is we can count how many jumps there are. So if we count, so there's going to be 1 jump, 2 jumps, 3 jumps, 4 jumps, 5, 6, 7 to get to the number 1. So that means our whole is considered out of 7. So we know the bottom of our fraction will have a 7. And then now we got to count where our dot happens. So our dot happened at how many jumps? So it happened at 1, 2, 3, 4 jumps. So that would be the numerator of our fraction. So the number graphed on this number line would be 4/7. Okay, so number 7 here. So we're simplifying an expression with division. So now there's a couple different ways to do this, but I think the best way usually is just prime factorization and canceling out common factors. So we know that when we have something divided by itself, that should result in 1. So if we can kind of break this thing down and divide out the forms of 1, meaning anything that's the same on top and bottom, then we're going to have our simplified fraction at the end. So 4 can be written as 2 times 2. And then x to the 6 can be written as 6 different x's. And this seems a little tedious at times, but I promise it will make life easier if you just go ahead and write it out. And then y squared will be y times y. Now, 16 is 2 times 8, but 8 is 2 times 4, and 4 is 2 times 2. So 16 turns into 4 2's being multiplied. Then we have 3 x's, and then we have 3 y's. So now what we're going to do is we're going to kind of look at this thing and cancel out common factors. Okay, so we are going to need to figure out, okay, so what's my common factors? So I have a common 2 here on top and on bottom, so I get to cancel those. I have a common 2 again, top and bottom, I cancel. No more 2's are common, so we're going to kind of stop there with our 2's. But we have some x's that are common, so we're going to cancel out some x's. So we got 1, 1. Cancel another set. We cancel another set, and that's all the x's we're allowed to cancel. Now we're going to do our y's. So we got one set of y's that can cancel, a second set of y's that can cancel. And that seems to be all of our common terms. So we are going to now see what is left. Okay. So if we look, Well, what is left over? So on top, it looks like we only have 3x's left. So that's going to turn into x cubed. Now on bottom, we have two 2's. So 2 times 2 will turn back into a 4. And then we have a y, and that's it. So our final result will be x cubed over 4y. Okay, number 8. So when we're doing number 8, again, parentheses are important. This is one you could punch straight into your calculator if you're very comfortable with the calculator and the fraction buttons. If you're not comfortable with those buttons, I would say talk to your professor, talk to your instructor day to day. Make sure they show you how to use these calculators properly because they will help you with these fraction questions. And they're pretty nice and quick to plug in so you can spend time on other questions on the final. But we'll kind of go through the process by hand, but just know you can always check these or do these in a calculator as well. So if we're doing this by hand, we got to do order of operations, which means we have to focus on the parentheses first. So inside of our parentheses, we are adding fractions. In order to add fractions, we have to have a common denominator. So right now, we have an 8 and a 3. That's not going to work. So we need to have those be the same number. That way we can add those two fractions together. So our common multiple between 8 and 3, if we were to think about it, so our LCM would be 24. Okay, so our LCM for those would be 24. And again, if you need help doing an LCM, go back to number, I believe 3 it was. Think about how we would get that and see that you can get 24. So if we're trying to create 24 as our common denominator, then what we're going to do, okay, we're going to do 5 over 8 plus 2 over 3. Now, we need to have 24s on the bottom. So if we're going to get a 24, we're going to need to multiply the first fraction by 3 on the bottom to get to our 24, because 8 times 3 is 24. But if you multiply the bottom, you also have to multiply the top. Now, for our second fraction, 2/3, to get to 24, we're going to need to multiply the bottom by 8. But if you multiply the bottom, you also multiply the top. So this will create equivalent fractions that now have a common denominator. So when we do the multiplication, 3 times 5 is 15. And then we know our bottom will be 24. Okay, 2 times 8 is 16. And again, we know our bottom will be 24. So now that they have a common denominator, we can actually add the tops. So 15 plus 16 will be 31 over 24. This will be the result of adding our fractions. But remember, that was only one part of our equation. So now we have to actually do the rest of it. So now we got to do 3/4 divided by 31 over 24. Now, we don't like to divide fractions usually. So here's where we have to kind of think about what to do. So usually with division of fractions, we want to use the mnemonic keep, change, flip. So we're going to keep the 3/4 the same. And then we're going to change from division to multiplication. And then we're going to flip the second fraction upside down. Now that we are multiplying fractions, we can go straight across and then simplify from there. Okay, so since we're going straight across, we know we're going to have 3 times 24, which will be 72. And then 4 times 31, which will be 124. Now we're just going to simplify this fraction by finding common factors, okay? So we think about what divides into both of these, and we can kind of try a few numbers. But 4 will definitely divide into both. So we're going to divide by 4. So if we divide each one by 4 to simplify, what are we going to get? Well, if we divide by 4, the numerator will turn into an 18, and the denominator will turn into a 31. Now these, unfortunately, have nothing in common, so this would be our simplified fraction. All right, so now we're moving on to number 9 here. So for number 9, we are solving a linear equation. So now we have an equation. So when we have an equation, that means we have two sides that are set equal to one another or some relationship between one another, but usually equal. And having an equation is very nice because it allows us a lot more freedoms in how we kind of simplify and solve. So since we have two sides set equal to each other, we are allowed to do whatever we want as long as we do it to both sides equally. Because these are equal, so as long as we change both sides the same way, we can do kind of whatever we want. So we want to try to get x by itself so we can solve this equation. So in order to get x by itself, we're going to kind of add, subtract, multiply, divide things to kind of clear out the extras to try to get x all by itself. So the first thing we're going to do here is we're going to distribute our 3. Okay, we're going to get rid of those parentheses. We need to get rid of those. We're going to try to get all of our x's combined, so we don't like to have parentheses when we do that. So if we do that, we're going to have negative 5x still. Now 3 times 2x is 6x positive. 3 times 5 is 15. And that's now equal to negative 8x minus 1. So now we're going to combine like terms on each side of our equation if they have any. So we do have like terms on our left-hand side here. So negative 5x plus 6x is just going to be 1x plus 15 is equal to negative 8x minus 1. So now once we've had things combined, we're going to try to get x's together and numbers together. Because in the end, we want to have x equals our answer. Okay, so we get to move things around as we want, but just remember, anything we do to one side, we have to do to the other. So what we'll do next is we're going to add 8x to both sides, because if we do so, it will cancel the negative 8x plus 8x on the right-hand side, but it will combine the like terms on the left-hand side. So if we do that, we're going to get 9x plus 15 is equal to, well, these will cancel, negative 1. Now, from here, we need to get our 15 moved over because, again, we're trying to get x by itself, so that 15 does not have an x. So if we have an addition of 15, to move it over, we are now going to subtract 15 from both sides of our equation. And again, whatever we do to one side, we have to do to the other. That way, these will cancel, and that's going to result in the equation of 9x is equal to, well, negative 1 minus 15 is negative 16. Now all we got to do is get rid of our 9, and we have x by itself. So if we have 9 times x, the way we would get rid of that is division, because the opposite of multiplication is division. So now we would divide both sides by 9. That way these will cancel. We'll get x is equal to negative 16 over 9. We would think about if this simplifies. Well, nothing goes into both 16 and 9, so no, it will not simplify, so we have our final answer. Now, if you wanted to check to make sure you got the appropriate final answer, all you would have to do is plug this number in to each of the x's in the original equation and show that both sides are indeed equal to one another when we evaluate it. Okay, so if you ever want to question it, that's a way to check it. That way you make sure you didn't make a mistake along the way. Okay, number 10. So this one is more of a multiple choice question. Okay, so it says which equation has no solution. Now, if an equation is to have no solution, that means that the two sides of our equation could never be equal no matter what x is. Sorry. So that means we're going to have to figure out which of these equations, if we tried to solve it, would never give us a result because it couldn't happen. So with equations that have no solution, kind of what they have to kind of look like is they have to be able to, when you solve them, the variable will have to cancel. And when that variable cancels on both sides, meaning no variables will be left, the statement we have left has to be untrue. So let's just start with solving some of these and see which one maybe results in that. So you can pick whichever one you want to start with. So if we just solved A, right? So if I tried to sit here and say, okay, well, look, maybe we think it's A. So if we try to solve for A here, we're going to try to move our x's together just like we did in the last question, try to get x by itself and see if it has an answer or not. So what we would do is we would subtract 2x from both sides. of our equation to get our x's together. Now, if we do that, we're going to get negative 1x minus 9 is equal to 3. Well, our x's did not cancel there. So we still have an x in our equation, which means this one's going to have a solution. So we can kind of stop here and say, well, that one has a solution, so it can't be A. So now we're going to move to the next one. Okay, so we're going to solve B now. So this was A's choice. So if we solve B, well, if I say 3x minus 9 is equal to 3x minus 3, again, we're going to try to get our x's together, so we're going to subtract 3x from both sides. Well, what we see happens is that cancels both of them on both sides, and it leaves us the equation negative 9 is equal to negative 3. Well, that is an untrue statement. Negative 9 does not equal negative 3, and now there's no way to fix it because our x's have canceled out. So this is what we're looking for. This is what happens when we have no solution. That means that these two equations will never be equal because there's nothing x could be that would ever make this equation true. So we found our solution. So B would be our final answer because it would definitely have no solution. Okay, number 11. So it tells us the price of a book plus a 6% sales tax comes out to $48.76. If X represents the price of the book, we want to write an equation to help us try to determine the original price of that book. Now notice it doesn't have a solve for the original price. It just says write an equation. Okay, so we're going to do that, and then we're going to solve for that original price once we have the equation. So when we do word problems, the equation is the most important part because you have to be able to take words and create an equation from that. So here we have a sales tax being applied to a book, and we know what we paid, but we don't know what the book was before the tax was applied. So that's what we're trying to figure out. So if X is going to represent the original price, so what we're thinking is if we went to a store, we would have original price plus our sales tax is equal to our total price at the end, right? So that would be the equation we're trying to create. So we have our book plus the sales tax for that book. That's going to be what we pay at the cash register. So they tell us that the price of our book, which is our original price, is X. So we're going to go ahead and sub that in for our original price. Now, it tells us that we have a 6% sales tax. Now, when we have percentages, we don't like to use them as percentages. We want to make sure those are decimals. So we would need to convert 6% into a decimal. Okay, and to do that, you would divide 6 by 100, and that decimal will be the decimal we're talking about. Okay, but since it's a sales tax, it's a percentage of something. This sales tax applies to what? It applies to the book itself, and it's being added on to the price of that book. So our sales tax would be 0.06 for 6% of the price of the book, and the price of the book we called X, so we're going to have an X with that as well, and that's got to equal our total price, which we paid at the cash register, of $48.76. So this is our equation. So we have our book, we have our sales tax, we have the total price, okay? Now we're going to go about solving this equation. So the good thing is they are like terms. So our x and our 0.06x are like terms. And again, if you want to think about it, there's an imaginary 1 here. So we're going to be able to combine those like terms. So if I have 1x plus 0.06x, that's going to give us 1.06x is equal to 48.76. Now, if that's the case, we're now going to solve for x. So we have 1.06 times x. So we're going to divide by 1.06 to get rid of it. That way we have x by itself. So 1.06. So x is going to equal whatever this turns out to be. Okay, so we would do 48.76. So this is where we would definitely want to use our calculator to make sure. So we're going to do 48.76 divided by 1.06. 48.76 divided by 1.06. And that's going to give us $46. which would be the price of our book. Now, before we finish out this question, we're going to need to think logically to make sure we haven't made a mistake. So if we were adding a tax on and we know we paid a total price of $48.76, the price of our book should have been smaller than $48.76, and that's what we got. We got 46, which is smaller. So it seems like a valid number. Now, if we would have got something bigger, that means something's wrong with our setup or something went wrong with how we solved it. So always think these things to kind of eliminate bad choices or catch yourself if you make a small mistake. But this is the general setup for any kind of sales tax problem. You have original price plus your tax has got to be your total price. Now, if you ever get a question that is a discount, it's a very similar process, a very similar setup. The only thing that changes is instead of adding on to the original price, we're taking away with a discount. So we would have, like X minus a percentage X is equal to our sell price. So it's a very similar setup, just slightly different because instead of adding on money, we're taking away money, okay? All right, so number 12. So number 12 here, we're solving an inequality. So an inequality is kind of like an equation. It's got two sides that have some relation. We're going to solve it just like we do an equation. So we're going to try to get x all by itself on one side or the other. It's up to us which side. Now, the only difference between this and an equation is if we multiply or divide by a negative. We need to turn around the inequality symbol when we do so, okay? Because what we're doing when we're doing that is we're flipping sides of the number line, so we have to change the orientation of that symbol. But that's only if we multiply or divide by a negative in solving, okay? So let's start out. So what we'll do is we have our equation, so we have negative 2x plus 6 is less than or equal to 3x minus 9. Now we're going to solve for x. So we can go either way with our x's. I don't usually like to play with negatives, but in this case we're going to just to show you that if we have a negative, we're going to flip that inequality. So what I'm going to do is I'm going to subtract 3x from both sides. That way these will cancel. We have negative 2 minus 3. That's going to create negative 5x plus 6 is less than or equal to negative 9. Now, again, we're trying to get x by itself, so we're going to subtract 6 from both sides of our equation. That's going to cancel here, so we're going to get negative 5x is less than or equal to negative 9 minus 6 and negative 15. Now, this is where we're going to now divide. So we have negative 5 times x. We're going to need to divide by negative 5. But since we're dividing by a negative, we now need to flip our inequality. So we divide our negative. The negative 5s will cancel. So we'll have x. But we need to turn our inequality around. So now it's going to be facing the x. And then negative 15 divided by negative 5 is a positive 3. Okay, so this is our final solution. So this says that x is greater than or equal to 3. This is called algebraic notation. Okay, so it's very important which notation the test is asking for because there's different types. So this one's called algebraic notation. It's one form of our answer. We also have notation called interval notation, okay? And the best way to do interval notation, in my opinion, is using the number line and kind of graphing out what it looks like. So if we were to think about a number line, we know at one end of that number line is infinity, at the other end is negative infinity, and somewhere along the way is our 3 number that we have here. So if x, our number, is supposed to be greater than or equal to 3, I'm going to need to go from 3 to the bigger numbers, which means to the right, towards our positive infinity. So we know that we're going to have our number line kind of shaded this way towards infinity, and it can be any number bigger than 3, so we're going to go all the way to that infinity. Now we have to determine if we're going to use a parenthesis or a bracket to close our intervals or not. So if we are allowed to equal the number in question, we're going to put a bracket. And if we're not, we're going to put a parenthesis. So since x is allowed to equal 3 because our inequality says x is greater than or equal to, we're going to put a bracket on our 3. Now on our infinity, that's a symbol that says it goes forever. So technically you can never include an infinity or equal infinity. So that side would definitely have a parenthesis. So now to do interval notation, we're going to use this graph. And the way it works is you're going to go from left to right, smallest to biggest. So we're going to start with our smallest number, which based on our graph is a bracketed 3, comma, to our biggest number, which is an infinity, which we know we're going to close in with a parenthesis because you can never actually equal infinity. Now, this notation is called interval notation. So these mean the same thing, but it depends on what the test is asking for. It will only give you one of the two notations, so you got to know how to convert from one to the other if it wanted interval notation, because you're always going to get algebraic from solving. Then you can go to interval notation once you have it. And again, using the graph is going to be your best bet. It just make sure you can read your inequality and then graph the appropriate thing. Okay, number 13. So here we have a bunch of letters and we're solving for y. So most students get afraid of these kind of questions because there's no numbers, but try not to think of it as like just a bunch of letters, okay? So like when we solve an expression or an equation for a variable, so like earlier we solved a bunch of things for x. What we're saying is we want to get that letter by itself by moving the other things over to the other side so we can get that letter by itself. And again, just like when we were solving earlier, we're going to use kind of opposites to try to move things from one side to the other. And as long as we do the same thing to both sides, we'll be okay. So what we're going to do here is we're going to try to solve for y. So if I have y here in the top of my fraction, and that's being divided by a. So the first thing we notice is that a here is dividing both the y and the z. So in order to get rid of it, we're going to have to move that first because it's affecting both things. So division of a can be canceled out with multiplying by a. So we're going to multiply both sides of our equation by a because that will cancel our division of a here, leaving us just y minus z is equal to c times a, which we're just going to leave as c times a, which we can write right next to each other. We can put parentheses around the a. We can leave the dot in between. All of that is fine notation. Now, if we're going to get y by itself, right now, z is being subtracted from y. So in order to move that, we're going to add z to both sides. That way it cancels on that side, but it won't cancel on the right-hand side. So these will cancel. And that's going to leave us the equation y is equal to c times a plus z. And that would be it because now y is by itself, which means we have our finished equation. Okay, so don't think of them as just letters. They are indeed numbers. They're just numbers. We don't know what they are. And we move them just like we would move any number if it was a number. Again, think opposites. That will always get you in the right spot. Okay, now for the next one. So 14 here, we're trying to fill in the blank. It wants to know what number is 92% of 450. Okay, so there's a couple different ways to solve this one. We're trying to figure out what number, when divided by 450, would give us 92%. So it's kind of up to us how we solve it, but what I like to kind of set up is like a kind of proportion here. So like we know that some number, so we don't know our number, we'll call it x, divided by 450, had to turn out to be 92%, but remember with percentages, we have to use them as decimals. So 92% is the same thing as 0.92. And again, if you forget how to get there, you take your percentage number 92, you divide by 100, and that will give you the decimal that it is. Okay? So in order to solve this for x, we have our equation. What are we going to do? Well, x here is being divided by 450, so just like in the last question, if we want to get rid of division, we're going to multiply by 450 on both sides. Okay, that way these will cancel. We'll have x is equal to whatever 0.92 times 450 is. So again, we'll use our calculator here. So we got 0.92 times 450, and that's going to give us 414. Okay, which will be the blank that we're trying to fill in. Okay, now if you wanted to check this, well, what you could do is again plug it back in. So 414 divided by 450, does that give you 0.92? So if we do 414 divided by 450 just to check it, well, we're going to get 0.92, which is 92% as a percentage. So perfect. So you can always check some of these things using the equation and kind of making sure it makes sense to the question itself. That way you catch any simple mistakes you might make. All right, jumping right into number 15 here. So we got an English teacher must read and grade 24 essays. If the teacher takes 21 minutes to read and grade 8 essays, how much time will they need to grade all 24 essays? So we got ourselves a little proportion ratio here. All kinds of different ways we can solve this one. We're going to use fractions to do it. In our case, when we set up our proportions as fractions, we need to make sure we're very consistent with how we set them up. So like we're going to set them up and we just have to make sure we're staying consistent with what we're putting on the top of each fraction and what we're putting on the bottom of each fraction, okay? So we're going to set two proportions equal to one another and try to solve for the unknown amount of time that we would need to grade the 24 essays. So we know that in our first scenario, we take 21 minutes to read 8 essays, okay? So that tells us that if we have 21 minutes, that would equate to doing 8 essays. Okay, we are going to set that equal to the other scenarios ratio, but again, since we put minutes on top here, we're going to also put minutes on top on this right-hand side. So for the next scenario, we're trying to figure out how many minutes it will take to do 24 essays. So we do not know the amount of minutes, so we're going to put an X. So it's X amount of minutes over 24 essays. So that way we've stayed consistent with our setup. We could have done this in the other direction, so we could have flipped them. It would have been fine as long as they're the same on both sides, meaning same units over same units, okay? Now, when you have a proportion like this set up, the way we solve for our unknown is we're going to use cross multiplication. So what we're going to do is we're going to multiply 21 by 24, and we're going to set that equal to where we multiply 8 by x. Okay, so if we do that, we're going to get 21 times 24 is equal to 8 times x, which is 8x. Now we're just going to solve for x like normal. So we're going to do 21 times 24. We're going to see what that gives us. So if we do 21 times 24, we should get 504. So this is going to say that 504 is equal to 8x. Okay. Now we're going to solve for x. So since it's 8 times x, we're going to do divided by 8. And we're going to divide by 8. And that will tell us what x needs to be. So if we do 504 divided by 8, we're going to get x is equal to 63 minutes. And if you kind of think about this logically, this will make sense because if we do 8 essays in 21 minutes, well, that means we can do 16 essays, which is double that, in 42 minutes. And then we can do 24 essays, which is 3 times the 8 amount, in 63 minutes, because that's 21 times 3 as well. So there's ways to kind of think logically about it and check them. Like I said, there's also plenty of different ways to do this. So, I mean, you could do it many different ways, but this is like usually the best approach because if they're not clean multiples, this will be the better approach than when they are. All right, so moving on to number 16. So a box contains 66 red marbles, 99 white marbles, and 10 blue marbles. If we're going to randomly select a marble out of the box, what is the probability that it will not be blue? Meaning anything but blue is good, but we do not want to pull blue, okay? So when we think probability, what we're thinking is like, the way I like to think of it is the probability of, let's say, an event happening is equal to like the number of times the event happens over the total number of outcomes possible. Okay. So if we want not blue, and our box here only contains 3 types of marbles, that means we want red or white marbles to be pulled. Okay. So if we want the probability of not blue, that's going to be the same thing as the probability of red or white. Okay, so when we think about it, okay, so we're going to go through it. Okay, how many red marbles we have? Well, we have 66 red marbles and we have 99 white marbles. So altogether, red and white make up how many marbles? So if we do 66 plus 99, that's going to create 165 marbles that are good. So if we pull any of these 165, we're technically doing what we're supposed to be doing. But how many total marbles are in that box? Well, there's also 10 blue marbles. So if we add 10 to this, there's going to be 175 total marbles. So the total number of outcomes is 175. So the probability of red or white, which is the same thing as not being blue, would be 165 over 175. And we just need to simplify this down to a better fraction. So we need to find a common multiple between 165 and 175. And we know that both of these are divisible by 5. So we're going to divide each one by 5 just to get a simplified version of this fraction. So 165 divided by 5 is going to be 33. And then 175 divided by 5 is going to be 35. And that would be the probability of not blue. Okay, so number 17 here. So we're doing a bunch of statistics on a set of numbers. So we need to know what the mean, median, mode, and range are first, and then we're going to find them. So in order to do some of these, it's going to be best to go ahead and put our numbers in order from least to greatest, because that's going to help find some of these things. So that's the first thing you kind of always want to do when you're doing statistics, is make sure your data is in like least to greatest order, because that's going to help find some things. So we're going to rearrange our numbers. So we're going to start with our smallest number, which looks to be a 14. The next smallest, so if I take out 14, the next smallest is going to be, there's two different 24s, so we're going to put those in there next. So it takes our 24s away. The next smallest will be 32. The next smallest will be 83. The next smallest will be 91. And then we have a 103 and a 131. So now we have all of our numbers in order. We're ready to kind of figure out what these things are. So mean, when they ask for the mean, that's the same thing as an average. And the way we find average is we add all the numbers together and then divide by how many numbers there were. So our mean will be the sum of all the numbers divided by the amount of numbers. So if we add all these numbers together, so we'll have 14 plus 24 plus 24 plus 32 plus 83 plus 91 plus 103 plus 131. So our total sum turns out to be 502. And then how many numbers are there? Well, there are 1, 2, 3, 4, 5, 6, 7, 8 total numbers. So we're going to divide by 8. So 502 divided by 8 gives us 62.75. And this would be our mean. Okay, so again, mean is an average. So we sum up all of our values and divide by how many values there were that summed. Now, median is the middle number. And this is where it's important that they were in order. So we have the middle number. So now we have 8 numbers here. So there's technically not going to be one middle. So if you have an even number of values or data sets, then your median will be the 2 middle numbers averaged together. So we're going to find our 2 middle numbers, which would be the 4th and the 5th number. That is going to be 32 and 83 in our case, okay? So these would be our 2 middles. We're going to average those together. So remember, an average, we add them together, divide by how many there are. So in this case, we're going to do 32 plus 83. That's going to give us a sum of 115. And we're going to divide that by 2 because 2 numbers created that 115. So we're going to divide by 2. That's going to give us 57.5. So our median will be 57.5. Again, if it's an even number of terms, this is how we do it. Okay, if it's an odd number of terms, there's going to be a true middle, and we don't have to do the average like that for the median. Now, mode is the number that shows up the most. So it's the number that is most frequent. So if we look at our list, there's only one number here that happens more than once, and that's 24. So it will be our mode. Now, what's important about mode is you can have more than one mode. So if there was two different things that happened twice, both of them would be the mode. Okay, so you don't have to have only one mode. It just whichever the most amount that occurs, that is the mode. And if there's more things, if there's more than one thing that happened that many times, then you have more than one mode. Now, range is going to be the spread of the numbers that we have. Again, this is where it's important to have them in order as well. So the spread is going to be the highest number minus the lowest number. So in our case, that's going to be 131 minus 14, which is going to give us 117. Okay, so again, mean is average, so you add them all up, divide by how many there are. Median is your middle number. Okay, and if you don't have a true middle, you have to take the average of the two middles. Mode is the one that shows up the most, and range is the highest minus the lowest. All right, number 18. So now we're reading graphs. So number 18 says, find the difference in scoring averages for this NBA player from the year 2016 to 2017. So we have our scoring averages. We're going to look at 2016, 2017. And we're going to say, okay, well, we want to find the difference from 2016 to 2017. So this is where it's important, the direction. So in our case, we're going from 2016 to 2017. So when we do a difference, we want to do final minus initial. So in our case, final would be the 2017 average, which is 5.6. Initial would be the 9.3 average, which is the 2016 number. So 5.6 minus 9.3 is going to give us negative 3.7. So that would be our scoring average difference between the 2 years. So we dropped 3.7 in scoring average. Okay, 19, geometry. So we want to find the perimeter of a triangle with sides of 10 feet, 11 feet, and 3 feet. It's usually nice to draw a quick little picture on these. So I'll draw a triangle, which we know is three-sided. So one of those sides is 3 feet, one will be 10, one will be 11. Now, if that is the case, so perimeter for any shape, no matter the shape, is the distance around the shape. Okay, so in our case, if it's three-sided, our perimeter will be adding up the three sides. Okay, so in our case, perimeter is going to be 3 plus 10 plus 11, which is going to give us 24. Okay, so now if it was a rectangle, it'd be 4 sides, so we'd add 4 sides. But perimeter is always the distance around the shape. All right, number 20. So for number 20 here, we are asked to find the equation of a line that passes through the following point, 2, 4, and has a slope of 3. So it's very important that you remember what the equation of a line looks like for this for the final exam, because you will have definitely some questions about it. So remember, the equation of any line could be written as y is equal to mx plus b. Now m is the slope of the line, and b is the y-intercept. This is called the slope-intercept equation, okay? So now, in our question, they gave us the slope. So they gave us part of our answer for sure. But the y-intercept is a very special point. Okay, so it only is the y-intercept if it has the ordered pair 0, comma b. So they did not give us that because they gave us the point 2, 4. So since it does not have a 0 in the x spot, that is not b. So we have to use this point to find b. There are two different ways to do that. You can use the point-slope equation, or you can just use the slope-intercept equation, which we already have on the screen here. I prefer to use the slope-intercept equation just because it avoids all the negatives from the point-slope equation, but you can use either. You should get the same answer. It shouldn't matter which method you choose. So we're going to set up our equation. So we know our slope is 3. So I'm going to go ahead and plug that in for m. So we know we have 3x plus b. We're going to try to solve for b using the fact that our line passes through this point xy to 4. Okay? So we're going to plug those in. So we're going to get 4 is equal to y. We know our slope is 3. We know x is equal to 2. And we're going to try to solve for this b value now. So this tells us that 4 is equal to 6 plus b. Well, if that's the case, we're going to subtract 6 from both sides. And we'll get that b is equal to 4 minus 6, which is negative 2, because these will cancel. So now that we have b, we're going to come back and we're going to say, okay, if that's the case, we're going to plug b into our equation now. So I'm going to come over here, and I'm going to erase my plus b, and I'm going to now have a negative 2. So it's going to be 3x minus 2. And that would be the equation of my line. Now, if you wanted to double check it, you could just plug your ordered pair in, 2, 4. You could plug in 2 for x. 3 times 2 would be 6. 6 minus 2 does indeed equal 4, so it matches out that this does pass through that and has the slope that we're talking about. All right, 21, we're going to do it again, but this time they don't give us the slope. They just give us 2 points that our line passes through. So now we don't have anything that we need. We have to find both parts, m and b. So we're going to find m first. So now m is the slope, which can be written as rise over run. And it has the equation y2 minus y1 over x2 minus x1. So we're going to use our ordered pairs to find our slope. Okay, so in our case, m is going to equal, well, we're going to need to label our y2 or our y1s. So I'm going to go ahead and call this like x1 here and y1. This will be x2 and y2. Okay, so we can find our slope. So our slope will be y2, which is 1, minus y1, which is 3, over x2, which is 2, minus negative 6. So be careful with our negatives. We have a double negative there, so make sure we're putting parentheses. So this simplifies down to negative 2 on the top. 2 minus negative 6 is like 2 plus 6. So that's going to be 8, which simplifies down to negative 1 over 4. So our slope will be negative 1/4. Now that we have that, we're going to do exactly what we did in the last question. We're going to plug our slope in. We're going to use one of the ordered pairs to find our b. Okay, so we have, we're going to use the x2, y2. So we're going to say 1 is equal to negative 1/4 times 2 plus b. And we're going to try to solve for b here. Okay, so negative 1/4 times 2 is going to be negative 1/2. So now, in order to get b by itself, we're going to add 1/2 to both sides. Okay, so we're going to have b is equal to 1 plus 1/2. Because again, we're going to add the 1/2 to both sides. So 1 plus 1/2 is 1.5, which is the same thing as 3/2. So we know that b is equal to 3/2. Now that we have b and we have m, we can write our line. So our line will be y is equal to negative 1/4 x plus 3/2. And again, if we wanted to check it, we could check it with the other point, plug in negative 6 for x, simplify it out, and see if you get 3 for y. Okay. Number 22. So we're using our knowledge of intercepts to find the correct graph. So now, intercepts are very special points. So an x and a y intercept have very special spots on a graph. So the way it works is an x-intercept always has the fact that y will equal 0. And a y-intercept will always have the fact that x is equal to 0. So what we're going to do is we're going to solve this equation twice, where we plug in 0 for one of the letters and solve for the other, because that will be our intercept. So if we were to plug in 0 for y, then we're going to get 4x minus 6 times 0 is equal to 12, which means that 4x is equal to 12. So if we divide by 4 on both sides, we get x is equal to 3. So that tells us that our x-intercept, okay, so our x-intercept is the point 3, 0. All right. Now we're going to do that same thing, but this time we're going to plug in x equals 0. Okay, so I'm going to kind of space this out a little. So if I plug in x equals 0, we're going to have 4 times 0 minus 6y is equal to 12. That's going to be negative 6y is equal to 12. If we divide by negative 6, we divide by negative 6. That's going to tell us that y is equal to negative 2. So our y-intercept is the ordered pair 0, negative 2. So now we're going to figure out which graph passes through both 3, 0 and 0, negative 2. So if we look, 0, negative 2 will be somewhere down here. So A is out, so it can't be A. So 0, negative 2, somewhere down here. So this one looks okay. So we can't eliminate it, but this one 0, negative 2 doesn't work, so we're going to eliminate that one. And 0, negative 2 also works on this one. So it's one of these two now. Now we're going to use the 3, 0 line. So 3, 0 is over here. So 3 for x, 0 for y. So this one's also out, but 3, 0 is here. So this one has both, so it's going to be D is our final answer. All right, 23. So we are solving a systems of equations. Now again, there's multiple methods to solve these. You learn a few throughout the class. So there's graphing, substitution, or addition. Addition is usually the more friendly version in terms of like it will never create a fraction in our class. But substitution is usually the ones that students prefer the most sometimes, but you do have to be careful with fractions with that. So I'm going to show the addition method, but if you like the substitution method, then by all means, use that. You should get the same answer no matter which method you're using. But just be careful when you're using substitution. You could potentially have a question that creates fractions. And you don't really want to do that because fractions are much harder than whole numbers. So we're going to use the addition method. Now, the addition method, what it is we're going to try to add these equations together in such a way that when we add them, one of our letters will add to 0. That way we can solve for the other letter. So what we have to do is we kind of have to look at our question. If we was to add them right now, would one of our letters add to 0? Well, no, because 2 plus 1 for x is 3x. 4 minus 3 is 1y, so nothing cancels completely. So we're not ready yet. So if we're stacked like this, we're going to try to figure out something we can multiply the equations by in order for that way when we add them, we want something y to 0. So we have to choose what we would like to cancel, x or y. So I usually like to pick x just because it's on the lead terms there, so it's easy to kind of see what might make those cancel. So right now, if I rewrite my statement, so we have 2x plus 4y is equal to negative 8. We have x minus 3y is equal to negative 14. We're going to try to multiply something or both equations by something in order to be able to add these together in such a way that the x's will cancel. Well, there's an imaginary 1 on this x, so I need to make a pair of opposites. That way when we add them together, they will cancel. So if I have 2 and 1, then if I made the bottom x a negative 2, then 2 plus negative 2 would be 0. So what we want to do is we want to multiply this bottom equation by negative 2. That will create our opposites for x, and we'll be able to add them together. So if we do that, that's going to create two new equations. So the top one, we're not going to do anything because we like the positive 2 we already see. But now we're going to distribute this negative 2 to all three parts of our bottom equation. So that's going to create the negative 2x that we want. It's also going to create a positive 6y, because a negative times a negative, and a positive 28. Now we're ready to add these equations, and we're going to add them straight down. So negative 2x plus negative 2x will cancel just like we think. 4 plus 6 creates 10y. And then negative 8 plus 28 creates 20. Now we have a very nice equation to solve for y. So we're going to divide each side by 10 now to get y by itself. And that's going to tell us that y is equal to 2. Now that is only half of our answer. The solution to any systems of equations is an ordered pair where these two lines intersect. So we have the y coordinate where they intersect now. We need to use that to find the x coordinate. So what we're going to do now is we're going to plug this y equals 2 into any of the equations we have for y and then solve it for x. So we're just going to use either one. I'm going to use the bottom one. So we're going to say x minus 3 times 2 has to equal negative 14. Well, that says that x minus 6 is equal to negative 14. We add 6 to both sides. We're going to get x equals to negative 8. Okay. So that is our ordered pair now. We have x and y. So usually the way we like to write it is we like to write it as an ordered pair. X always comes first, so negative 8, comma 2. And that would be the solution to our system. Okay. And if you wanted to check it, you could just plug in x and y into both equations, make sure they actually work out to be the answer that they're supposed to be. Number 24. So we're multiplying polynomials. So we got two different binomials here being multiplied. So when we're multiplying polynomials, we have to make sure that we multiply everything in the first thing by everything in the second. So the way that will look is we're going to kind of use arrows here. So y here needs to be multiplied by 2y and by negative 3. Then we're also going to have to multiply negative 7 by 2y and by negative 3. So we got 4 things to do, and then we're going to combine like terms at the end if we have any. So if we do y times 2y. So let's do the first one. So we're going to do y times 2y. Well, y times 2y would result in 2y squared. Now we're going to do y times negative 3. That's going to be negative 3y. We're going to do negative 7 times 2y. That's going to be negative 14y. And then we're going to do negative 7 times negative 3. Two negatives will be positive, so that's going to be positive 21. Once you've distributed everything and you've got all your terms, now we're going to combine any like terms. Now remember, a like term is anything that has the same variable to the same exponent. So in our case, we only have 2 like terms here, the middle 2. So we're going to keep our 2y squared because it's all by itself. But negative 3 minus 14 becomes negative 17y's when we put those together. And then we still have our plus 21. And that would be as far as we can take it. Okay, so now this next one, and it's our last one here. It looks seductively simple, but this is one that people miss quite often. You got to remember what it means to square something, okay? Because what most students will do here is they'll just say, okay, well, 3x times 3x and 5 times 5, that's what this will turn out to be. They'll square each part separately, and they'll call it good. But that is exactly what you should not do, okay? And remember, to square something means we multiply it by itself. So what you would want to do first here is go ahead and write this out twice, because 3x plus 5 squared is the same thing as 3x plus 5 multiplied by itself. Now, once you have it written this way, it's much more clear what we're going to do. We're going to do exactly what we did in the last question. We're going to have to distribute each part to each part. So we're going to do 3x times 3x. That's going to create 9x squared. We're going to do 3x times 5. That's going to create 15x. We're going to do 5 times 3x. That's going to create another 15x. And then we're going to do 5 times 5, which creates a positive 25. Now, again, like last time, we're going to combine our like terms, which we have in the middle here. So we have 9x squared plus 30x, because 15 plus 15 is 30, plus 25. And again, this is one that people will miss quite often because it's very kind of easy to think, oh, I'm just going to square each component separately, call it good. Don't do that. Make sure you write it out and do the work, because this one, again, a lot of students miss it, not because they don't know what to do. They just kind of bypass the work of it and think they can do it without writing it out. Okay, so that was our review sheet. Hope it helps. Again, you need to practice, so there's multiple review sheets on Blackboard. If you have any questions on anything from this video, just make sure you ask your instructor before you take it. Hope it helped, and good luck on your final when you take it.